Okay, so let's take a look at what a calorimeter is. Calorimeters are special containers used to measure the temperature when substances are mixed. The name comes from the old unit of energy, the calorie. Okay, now what a calorimeter is trying to do, you take two substances in a calorimeter and you mix them. So you could make this calorimeter and give it a certain amount of cold water. Then you could put a little piece of hot metal in it. The hot metal would change the temperature of the water, and you could measure how much the water changes. Now, a calorimeter has to be insulated away from the environment so that no energy is lost into the environment. Right? We don't want heat to be lost to the surroundings. We want all the heat to be lost into the water. So you can build a simple calorimeter with two styrofoam cups, a cup lid, a stirrer, and a thermometer. Put it in, fill it with some cold water, measure the temperature of the water, drop in a piece of hot metal, measure how much the temperature of water goes up. You can compute the specific heat capacity of that piece of metal, figure out what metal it is. Or you could do a chemical reaction in here. Okay, one of the chemical reactions you're going to do in a calorimeter at the end is just dissolving salt. You take some water, dissolve some salt, measure the temperature change as the salt dissolves. Sometimes it makes it colder, sometimes it makes it hotter. A more advanced one would be a metal container. You got a metal container. It's aluminum. It's got a little place inside to put your stuff. Insulated supporting ring. Insulated cover, thermometer, stir. Right? The whole point is that you keep this whole reaction, this whole exchange of heat, isolated from the surroundings. Now, we're going to take a look at this example, which includes a calorimeter. A 0.500 kilogram piece of lead at 100 degrees Celsius is placed in a 0.200 kilogram of water 20 degrees Celsius, which is contained in an aluminum calorimeter that has a mass of 0.400 kilograms. The final temperature of everything is 24 degrees Celsius. Find the specific heat capacity of the lead. Okay, so let's sketch this situation out. So we got three substances this time. So we've got our calorimeter. What do we know about our calorimeter? Well, it has a mass of 0.40 kilograms. 0.400 kilograms. We're going to label that mass. We know that the change of temperature for the calorimeter, it went from 20 degrees Celsius up to 24 degrees Celsius. So its temperature went up plus 4 degrees Celsius. Now, we know the specific heat capacity of aluminum because we need to know that one, 0.90. That's the calorimeter. Then we've got the water. Our water is mass of 0.200 kilograms. Right? It's important to label everything out. Our change in temperature for the water is, again, plus 4 degrees Celsius. Now, how do I know that the water and the aluminum were the same temperature at the start? They're both 20 degrees Celsius. Because of thermal equilibrium. If that water was sitting in that aluminum can for any amount of time, the water and the aluminum can would have achieved thermal equilibrium, the same temperature. And we know the specific heat capacity of water is 4.18. Then we've got the lead ball. Then we've got the lead. We know the mass of the lead, 0.500 kilograms. We know the change in temperature of the lead. It started at 100 and it dropped down to 24. That's negative 76 degrees Celsius. The specific heat capacity, we do not know. Now we know that the lead was hot. So at the end, the lead took energy and put it into the water and the calorimeter. That raised the temperature of the water and the calorimeter up. And the amount of energy that it took to raise the water and the calorimeter up in temperature is the same as the amount of energy that the lead lost. So let's figure out the water. Gained energy. Q equals mc delta T. We know all this stuff. Q equals 0.200 times 4.18 times 4. 0.200 times 4.18 times 4 is equal to plus 3.344 kilojoules. That's how much energy the water gained. Now let's look at the calorimeter, the aluminum. The calorimeter gained. Q equals mc delta T. Q is equal to 0.400 times 0.90 times 4. Q is equal to 1.44 kilojoules. All right, so now how much are those two together? So the Q in total is equal to plus 3.344, 4.784. Sorry, 4.784. Yeah, that's what I said. Kilojoules. So that's the total energy gained by the water and the lead. Or sorry, by the water and the calorimeter. Where did all that energy come from? All that energy came from the hot lead ball that was dropped in. So this is the amount of energy that the lead lost. So now let's deal with the lead. And yeah, this gets pretty tight down here. Q equals mc delta T. Now, this was a positive amount of energy because the calorimeter and the water gained it. It will now be a negative amount of energy for the lead because the lead lost it. Times C times negative 76. Now I combine these two numbers together. 0.5 times negative 76. I get negative 38. Divide both sides by negative 38. So negative 4.784 divided by negative 38, and I get 0.13. Kilojoules per kilogram degrees Celsius. That is the specific heat capacity of lead. I can go to my sheet and I look at lead, and lead is 0.13. All right, so with the calorimeter involved, it's a little bit more complicated. The important thing to remember is that something loses the heat energy and something gains the heat energy. And the amount that's lost is equal to the amount that's gained. All right, so now you are going to go and you are going to do these practice problems. All right, so question 1 is kind of like the first one that we did with the water and the water at different temperatures. You just kind of do the average of the. Then 2, 3, and 4 are like the 2 examples that we did. I want you to try them first, and I will make a video of questions 1, 2, and 3. So you can check questions 1, 2, and 3 when you're done.